So we're going to look at a type of reaction here. This is a combustion reaction. And you can recognize it because it's got carbon and hydrogen. This is called a hydrocarbon plus oxygen. And your two products are always going to be carbon dioxide and water. So to balance it, let's split it up into our reactant and product side. And let's list the elements. So carbon, hydrogen, and oxygen. Carbon, hydrogen, and oxygen. So we have a subscript of 4, we have 4 carbons, we have 10 hydrogens, and 2 oxygens. On a reactant side, over here we have 1 carbon, there's 2 hydrogens, and then we have oxygen in 2 spots. We have 2 oxygens here, we have 1 here, so we have a total of 3 oxygens. So the first thing we're going to do, and remember we always want to try to do oxygen and hydrogen last, balance those last, is let's do carbon. So we have 4 carbons on this side, so we need 4 carbons on this side. There's 1 carbon in the formula, so what times 1 will give us 4? And of course the answer is 4. So now we have 4 carbons, but we've also changed oxygen. So now we have 8 oxygens here, plus 1 here. So now we have 9 oxygens on this side. Next, we're going to balance hydrogen. So we have 10 hydrogens on this side, and then we need 10 on this side. So hydrogen has a subscript of 2, so you think to yourself, what times 2 will give me 10? And 5 times 2 is 10, so we put a 5 here. Now we have 10 hydrogens on this side, but look, we changed oxygen too. There's 1 oxygen in water. 5 times 1 is 5, plus we had 4 times 2, 8, so we had 8 here. 8 plus 5 is 13. So we need 13 oxygens on this side. Now, oxygen is a special case. So if you remember bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. These are the 7 diatomic molecules. Basically, these elements come in pairs. Most of the time, we can never have half of anything in chemistry or any like atoms or compounds because you can't have half of an atom. But what's half of O2? O2 is a special case because half of O2 is an oxygen atom. So for these 7, we can actually use coefficients that have halves in them, but then there's a trick to get rid of them. So first thing we do, we need 13 oxygens. So what times 2 will give us 13? Well, 6 times 2 is 12, and then we need a half. So 6.5 times 2 will give us 13. So let me squeeze a 6.5 in there. So 6.5 times 2 is 13, and now it's balanced. Now, you could balance it without using the half, but it makes it much more difficult and you just have to kind of keep going. So try to remember this trick. Now, we want to get rid of this 6.5 though. In the final equation, we don't want a half. So what times 6.5 will give us a whole number? And it's pretty much just going to be 2 because 2 is going to get rid of that half. So 6.5 times 2 is 13. So this coefficient is 13. And if we multiply this coefficient by 13 to keep all the ratios the same, we have to multiply everything by 13. Sorry, by 2. So this becomes 2. And then 2 times 4 is 8. And then 2 times 5 is 10. So here's our balanced equation.